discuss is using the chain rule. Now, the chain rule, we can actually have a statement dy dx can be equal to dy du multiplied by du dx. If we have got this statement, it defines what is called the chain rule. Now, for example, we can actually have a statement y is equal to u to the power 5. So for us to get the chain rule, we can say y prime is equal to, we actually know that y prime is equal to 5u to the power 4. Now, let, in this case, u be equal to 1 minus x to the power 4. Now, if u is equal to 1 minus x to the power 4, it means that I should be able now to say y is equal to bracket 1 minus x to the power 5. So it's like this, and here to the power 4, and here to the power 5. So it's like that. So if I want to say what is y prime for this, so first of all, I need to know what is my u. Then I need to know how I can differentiate the y. So these are the two parts. So in this case, you remember, it's u to the power 5, and then u is equal to 1 plus x to the power 4. So in this case, what you normally do is you actually can be able to find the derivative of this. So in this case, is y prime is equal to 5 u to the power 4, and then u prime in this case is equal to 4 x to the power 3. So if we now want to differentiate that one, so it is going to be now dy. Okay, let me change the color. If we want to differentiate that one, so it would be dy dx is equal to dy du multiplied by du dx. So in this case, you will just take the product, because this one is equal to dy du, and this one is equal to du dx. So we can say dy dx for this particular statement then is equal to 5 bracket 1 plus x squared, x to the power 4 to the power 4, and multiplied by du dx, which is equal to this one. So multiplied by 4 x to the power 3. So in the process, we can now be able to say this is 20 x to the power 3 bracket 1 plus x to the power 4 to the power 4. So this is actually the value. So I want you to understand this and be able to apply them in a context. And on the other part, we can be able to have another example, like find y prime if and only if I've got 10 on top there, and I've got x to the power 2 plus 4x plus 5 bracket squared. So you can actually say now on this one, you can actually take, no, here it must be to the power 7. So you can actually take, you can actually say let u, this is the same as y prime, find y prime. So this is the same as y is equal to 10 bracket x to the power 2 plus 4x plus 5 negative 7. It's the same as that. So when you have got something like this, then you can be able now to start say, so what you let u is equal to the thing that is in the bracket. So it will be u is equal to x to the power 2 plus 4x plus 5 is equal to u. So in this case, it will be now u to the power negative 7. Okay, because this is u. This is u. Now in that case, now you will be able now to say dy. Now what is now dy du? Dy du in this case is equal to negative 7 u to the power negative 8. Why is negative 8? Because I've taken negative 7, negative 1, then giving me negative 8. Then what about u du now? What about du dx? Du dx, in this case, you take now this equation and then you determine the value for du dx for that. So in this case, it will be now 2x plus 4. So this is du dx. So this is actually the expression 2x plus 4. Therefore, when it comes to that, so you can actually say du dx is equal to dy du and du and dx. So in this case, when you do something like that, then you can be able now to take whatever you solved. And this one, 2x plus 4, it is the du, and then the negative 7, so you put bracket, you can bring this back, negative 4x positive 5 and to the power negative 8. So this is actually the value for dy dx. That's the way we normally can be able to do that. And on the last one, we can actually look at the following. We can actually look at the following statement to say, what about when y is equal to x to the power 3 plus x to the power 2 to the power 50. So your u is going to be equal to x to the power 3 plus x to the power 2, and your du dx in this case is equal to 3x squared plus 2x, and du that's dy now du is equal to this is okay, is going to be equal to u to the power 50, which is equal to 50 u to the power 49. Therefore, then in this case, you can actually now say the final one, now dy du dy dx is equal to dy du multiplied by du dx, which is going to be equal to 50 bracket u to the power 49, u to the power 49 multiplied by 3x squared plus 2x. So finally, this is going to be equal to 50 and multiplied by 3x squared plus 2x bracket multiplied by 3x squared plus 2x. So this is actually the value which can be obtained by getting this statement. So I want us to have a practice of these so that we should be able to solve any problems that can be given to us. Now let's look at how we apply these particular statements in context. Sometimes we can actually have an exponential function. Now for exponential function, if y is equal to e to the power x, y prime, which is the same as dy dx, is equal to e to the power x, whereby if y is equal to natural log of x, if y is equal to natural log of x, then the situation differ. Because we must be able to know how we can be able to differentiate the natural log. So if we say y prime in this case is equal to 1 over x, so that's actually the natural log of a function. So we must be able to know that if we have a natural log, then this can simplify like that. So if we say y double prime of this one, then it will be to the power 2. So it goes like that. So we can actually say that whereby if we have got now, yeah, so the other points becomes a bit simpler. Now, so we'll stop there so that we can now look at the application behind these mathematics. How do we apply them in understanding some things in context? So we'll be able to look at it in the next class that we'll have on that point. Thank you.